So, like I said, it's 4:30. You're here. I'm here. Let's get started. What we have today is 101 questions. 2 hours to complete 101 questions. That's like a minute per question. But the way we're going to tackle these is there's a section, part one, which is 17 true/false questions, and then each of the sections that follows, there's a series of simpler questions. So, it's your formatting. We have independent variable, dependent variable, nature of the relation. What's the actual value of R, the correlation coefficient? What's the value of R squared, coefficient of determination? Solve for B. Get the test statistic. Solve for, I don't know why B comes first here. That seems odd. I don't know why G comes before F. Hopefully it doesn't do that same way all the way through. Yeah, apparently only does it for that first one. But yeah, it's still, what's the independent variable? What's the dependent variable? Describe the nature of the relationship. What's the value for R? What's the value for R squared? What's the value for the test statistic? Solve for B, solve for A, and then predict y hat if x equals 7. And we do that, I think, 11 times. And that's what we do. And once we get through that, we'll be exhausted with all the hypothesis testing that we've done. We should be good at all the hypothesis testing we need to do. We should be prepared to do simple linear regression for the quiz tomorrow and the exam on next week, depending on who you are. And then you're done with stats. Hooray! Right? Cool. Now I'm going to switch back and forth between the document camera and Excel. If you've got your machine handy, make sure that you do open the Excel document. Right when you open the assignment from homework assignments and you select homework assignment 10, this is the opening page before you begin assessment. Make sure you select and download this workbook, because this workbook contains the data sets and the scatter plots and the questions for all of the different examples that we're going through. If you don't have this, it's hard to do everything else. Cool. Question one, true or false? A scatter diagram, otherwise known as a scatter plot, is a graph that portrays the correlation between a dependent variable and an independent variable. True or false? Can you see whether or not there's a correlation by looking at a scatter plot? Alex? Yeah. So therefore, yeah. True. Number one is true. 100 to go. An economist is interested in predicting unemployment rate based on GDP. Since the economist is interested in predicting unemployment, the independent variable is GDP. True or false? If we're going to use GDP to predict unemployment, GDP is the independent variable. What do you say? What do you say? True? I got two trues over here. Do y'all agree with Rachel and Colin? I think I would too. You've established my trust at this point. I believe you. This is true. You use the independent variable to predict the dependent variable. 2 down, 99 to go. 3, the strength of the correlation depends on the sign of the correlation. True or false? The strength depends on the sign. What do you think, Cassie? False. I say false as well, because you can have a strong negative or a strong positive. False is a very good answer. What's happening? Number 4, the coefficient of determination is the proportion of total variation in y that is explained by x. The total proportion of variance. Total proportion of variation in y, which is the dependent variable, explained by the independent variable. True or false? What do you say? True or false? Thoughts? How about this? What is the thing that we were talking about on either Wednesday and or Tuesday, Monday, that is the total proportion of variation in y explained by x? We did go over that thing. Whether or not you know what it was called. Do you know what it was called? The thing that we used to describe that? How much variation was explained? It is r squared. Do you know what r squared's got a synonym? R squared's got a synonym. Do you know what r squared synonym is? I'll give you a hint. It rhymes with coefficient of determination. R squared is the coefficient of determination. This statement is true. That's the definition of the coefficient of determination. Now, we call it r squared more than we call it coefficient of determination, but I think on your final exam, if you know that the symbol of the coefficient of determination is r squared, you will get at least 1% of the final exam correct. The other 99% is up to you. But I'm telling you that there's a question on your final exam that looks like that. Assuming I don't change it between now and, well, whenever you take it. Number 5, the coefficient of determination. Hey, Colin, what do we call that thing?
Oh, r squared.
Yep. R squared is the square root of the coefficient of correlation. What's the symbol for coefficient of correlation? What's that symbol? Is r squared the square root of r? What do you think? Is r squared the square root of r? No. So I'm going to call this one true or false. Right on. 5's A. 5 down, 96 to go. One underlying assumption for linear regression is that the independent variable x is normally distributed. Was that ever part of our conversation? In fact, no, it was not. If that were the case, if you could only do linear regression with normally distributed independent variables, it would be a bit of a challenge. We do not hold that assumption to be the case. We talked about that. You may have read about it, you may have heard it in the lecture video, but no, it is false. Ooh, here's another one you might see on your final exam. The values of A and B in the regression equation are called regression coefficients. True or false? A and B are coefficients. John, looks like it's on the tip of your tongue. Or the tip of your teeth.
I was going to say, I know one of them is a coefficient. I don't know if both of them.
Yeah, they're all coefficients.
Oh, okay.
A and B and r squared and r, they're all coefficients. Coefficients is a very important word. Those are coefficients. Very good. 7 down, I'm losing track. 8, the regression equation is used to estimate the value of a dependent variable based on a value of the independent variable. Is that what the regression equation is used for? Rachel nods her head yes. Do you agree with Rachel? Alex, do you agree with Rachel? I would agree with Rachel. I would agree with Alex. I would agree with both of you. It's true. 8 down, 93 to go. Number 9. Because the coefficient of determination, otherwise known as coefficient of determination, otherwise known as, is expressed as a percent, its value is between 0 and 100. What do you say, Julia? Percent between 0 and 100?
It's like between 0 and 1.
Otherwise known as and expressed as a percent.
Oh, okay. So true.
Yeah. 0, between 0 and 1. 0 is 0%, 1 is 100% between 0 and 100%. Well, yes. 9 is true. 9 down, 92 to go. Number 10. What is the range of values for R, the coefficient of correlation? Or the correlation coefficient. Staples are dumb. There we go. What's the range of values that R can take on? R is a bounded statistic. Its minimum, its maximum, John?
-1, 1.
-1 to +1. You can have a perfect negative correlation. You can have a perfect positive correlation. -1 to +1, 10 is C. 11. If the correlation coefficient between two variables equals 0, what can be said about those variables x and y? If the correlation between x and y is 0, what do we say about x and y? I mean, we can find the right answer in a second, but if the correlation between them is 0, what's the conclusion?
They're not related.
They're not related. Is there an option that says that?
Yes.
Take that one. "11, they are not related." Number 12. Hey, we don't have that many to go. 12. If we reject the null. See it. If we reject the null, what can we conclude about the population correlation coefficient? If we reject the null, it could be 0, it is 0, it is greater than 0, it equals the sample correlation, or it is not 0. What do you think? If we reject the notion that it is 0, we conclude that it is not 0. That's the same thing we've been doing with hypothesis testing from the get-go. If you reject the idea that rho is 0, I really should have put the slash through like right here. You conclude HR that rho is not equal to 0. Non-directional hypothesis, you conclude it is not 0. Granted, R is your best guess or your point estimate, but it doesn't necessarily mean that rho equals R. Not necessarily. 13. Looks like we're going to go through our A, B, X, and Y hats. What's A represent in the regression equation? What's A represent? Hey, Caroline, what's A represent? Do you know? It is the y-intercept. So one more time.
The y-intercept.
A is the y-intercept. Yep. Because when we write y hat equals A plus bx, it's sort of like back in the day when we learned y equals mx plus b, except we stopped calling b, we started calling it a. Instead of calling the slope m, we started calling it b, just so we can confuse each other. But ultimately, a is by itself, so it's the y-intercept. What does b represent, John?
Slope.
B is the slope. A is the y-intercept. 14, B is the slope.
That's your concept.
What's up?
So the actual regression equation is the y hat equals a plus bx.
That's correct.
Then do the other two, like the b equals r, yada yada, and the a equals yada yada, those have a specific name?
Those are formulas for the regression coefficients.
Okay.
A is a coefficient, B is a coefficient. Both of those things have formulas, so those are formulas for those coefficients.
Thank you.
Yep, good question. I mean, if we wanted to get like really crappy, we could say that's the formula for the regression. That doesn't involve letters A or B, but I don't want to write that. No, and I even left out X bar, which needs to be in there too. See, that's just nonsense. Let's just simplify it. 14 down. Subtraction is hard. 15. What is x? 15. What does x represent? A is the y-intercept. B is the slope. X is... John.
Independent variable.
X is the independent variable, also known as the input, also known as the antecedent. X is the independent variable. Oh. Well, I'm sort of down to so many options. We've already gotten rid of the slope. Gotten rid of the independent variable. Y, what's y represent? John?
Dependent variable.
Also the dependent variable. Right on. Y is the dependent variable. IV is x, VB is y. Horizontal, vertical. $17. DF. Or correlation. In other words, T. When we have T, we need degrees of freedom, and we're doing a hypothesis test for the correlation. How many degrees of freedom, Rachel? N minus 2. N minus 2. It's a bivariate relationship. N minus 2. Right on. Hey, 17 questions about correlation and regression. Identify the different parts, know the properties of R, know what they're called, correlation, coefficient of determination. 17 concept questions. Now the next subtraction is hard. I want to say 84, but it could be wrong. All relate to, no, that sounds about right. Yeah, all relate to correlation and regression. I think the last two are different from the other ones. I think the last two are actually hypothesis tests. But otherwise, we're just setting up regression, talking about which one of these is the independent and dependent variable, which is 18 and 19, what's the nature of the relationship, and so on. So in order to accomplish that efficiently, I know what the list of questions are, and you have the list of questions in Sakai. But since in order to answer these questions, we need to use Excel, I'm going to keep Excel running up here and walk through anything that we need to do to execute the problem. And you can keep track of the questions. Then when we're done with each of the parts, we'll go back through and make sure we've got the answers to all the questions. Sound good? All right. So that was part 1, true, false, multiple choice. Part 2. Part 2. Stop showing me that. Part 2. So the following observations were randomly selected. We have x variables and we have y variables. We have x and we have y, and we have a scatter plot here. We need to know which one is the independent variable, and that's along the horizontal axis, and one of them is the dependent variable, it's along the y-axis. In this case, it's I think problem 2 is just called a pun, x's and y's. And I understand, I don't know if there's any grammarians or grammaticians, or I don't know what the word is for people who study grammar, ironic in the Alanis Morissette kind of way. I don't know why there's apostrophes here. It's just to make it easier to read. I apologize if I'm violating apostrophe law. But x and y. X is always going to be the independent variable. Y is always going to be the dependent variable. They're labeled as such. I didn't try to do something tricky where I made the vertical axis x and the horizontal axis y, because that's dumb and tricky, and you're just a bad statistician if you try to do something like that. It's just bad form. But one of these is the independent, one's the dependent. Which one's independent, which one's dependent?
X is independent, Y is dependent.
X is independent, Y is dependent. Those are the first 2 questions. Number 3 is what's the nature of the relationship? It could be non-existent, it could be perfect, it could be weak, moderate, or strong, it could be positive, or it could be negative. Does this appear to be, with this limited number of observations, small number of observations, Does this appear to be a relationship of any sort? Do you think there's a relationship between X and Y? Just looking at those dots. Alex, what do you think? All right, you got to pick one, yes or no.
Yeah.
Yeah, I'm going to go with yeah, too. And whenever you can identify the nature of a relationship, it is a positive relationship. When you can identify a relationship with a small number of observations, there's a pretty good chance that it's actually rather strong. Because it's hard to identify relations when there's not much evidence. The correlation between these two variables is 0.75. I would interpret 0.75 as a strong relation. 0.25 is weak, 0.5 is moderate, 0.75 is strong, 1 is perfect, 0 is non-existent. Just somewhere along that evenly spaced scale. Is it positive or negative? Yeah, how do you know? What's the sign on that correlation, Joe? Yep. The pattern's going up, but what's the sign on the number? It's positive. So if that number is positive, it's a positive relationship. So it's a relation. It's a technical thing, relation versus relationship. But what do I know about relationships? So 20 is strong and positive, something else I know nothing about. The value of the correlation coefficient appears to be right here. The value of the correlation coefficient is 0.75. The value of the coefficient of determination. Hey, Colin, what's the coefficient of determination? R squared. So, I mean, R squared, say, give me that and square it. R squared should be somewhere around 57%. If one of those options says 57%, it doesn't, or does it? Of those options, I heard a yeah. Who said yeah? Yeah, what do you say, Caroline? E, so 0.57. No. There we go, 0.57. 0.57 is 57%. 22, 57%. By the way, there's a couple of those that we should be able to eliminate immediately when it comes to the value of the coefficient of determination. Which two of those can we eliminate immediately? You can eliminate 2 immediately. Jill? A and F. Why? Yep, you're never going to square a number and get something negative unless it's imaginary. And by the way, if I tell you that R squared equals 0.57, can you tell me the value of R? I tell you R squared is 57%. Can you tell me R? Okay, you take the square root. So if I told you that the correlation was negative 0.75, right? You can't. So an R of 0.75 or negative 0.75 both give you an R squared that equals 57%. If I give you R squared, you cannot tell me R. You can tell me the magnitude of R, but you cannot tell me the direction of R. And R has both the magnitude and the direction. Or 22 is E. And the rest of what we're after here, and granted, a couple of these are in the wrong order because G does not come before F, even for large values of G. We've got to calculate some stuff. So I'm going to skip to what the test statistic is first. This is a formula that I'm going to give you. R is 0.75 times the square root of n minus 2. N is 5. So degrees of freedom equals 3. Divided by the square root of 1 minus, hey, we just found R squared, 0.57. Means we get 0.75 times something like 1.732 divided by the square root of 0.43. I don't know what that value is. Probably something like 0.6. So I'm going to take 0.75 divided by 0.6 and get something a little bit more than 1 times something that's almost 2. And I think I'm going to get a value that's something like this. That's me just trying to shortcut my way through there. Again, if you have a programmable calculator, and if I were you, and I've totally been you, and did I ever tell you guys that I tried to fail statistics when I was in college? I tried to fail statistics when I was in college. I got this close. I got a gentleman's C- my spring semester senior year, which also sort of explains why I'm a bit militant about the expectations I hold for all of you, because I don't want you to be the people who almost don't graduate because of a silly little thing such as statistics. If I were you, and I have been you, I would program that formula into my programmable calculator if you can. I mean, that's going to cut down on the errors that you make industrializing your process. Just saying input R, input N, and boom, here's T. I don't know. What do you get when you actually calculate this value? Something like 2? 1.98? There you go. I didn't intentionally try to fail statistics. I got an A on the midterm because that stuff was easy. And then I didn't do anything for the second half of the semester because that stuff was hard. And then I learned and I grew up. Y'all are better than me, so don't hold yourself to any lower standards. 23, sorry. So we just did the 24. We did 24, but now we got to go back and solve for B. B equals R times the standard deviation of Y over the standard deviation X. So we got to go in there and calculate those values using Excel. Or if you don't want to calculate those values and you want to expedite the whole process, what do we do? If you want to find B and A real quick using Excel, what do we do?
Find the equation of the scattered line of this.
Yep, we're going to find the trend line. We're just going to say, hey, Excel, give me the trend line and identify the pieces that we need. So for part G and part H, we could just say insert trend line, though early on, I'm going to show you in Excel how to calculate those values as well, because it's, I mean, I could just show you the answers. Hey, by the way, the answer number 25 is D. That's not what we're here for. So I'm going to show you for the first couple examples how to generate those things in Excel, both using the trend line on the chart and calculating things with your data set up as a table to calculate B, to calculate A, and then I think the last part, part 9, or I, is to make a prediction. And I believe for all cases, I simply said X equals 7, because that made writing the questions easier if my input X was 7. So what you can expect on your quiz tomorrow and on your final exam is that you're going to generate B and A, and then I give you an input for X, and you solve for Y hat. So one way we could do this real quick is just say, hey, add a trend line, and then display the equation in R squared on the chart. So A should be 3.77, B should be 0.36. A is by itself, B and X always hang out. There. I mean, that's a shortcut. But I'm also going to calculate values over here. B, A, R squared. Done. Also, while we're at it, we can also use our trend line to solve that answer. If X equals 7, We go over to our horizontal independent axis where x would equal 7, seems to intersect our line about right here. So I would say if we have a y value that's somewhere between 6 and 7, like 6.5, do we have a y value, or a y hat value somewhere around 6.5? Now we got
6.31.
I'm going to guess when we solve it numerically, you're going to get something like 6.31. That little rectangle is called my marquee. With my marquee in my appropriately formatted table, Control-T will turn it into a table. And yes, my table has headers. Now this data is turned into a table, which, I mean, it still says observation X and Y, but it's changed my fonts. All right. It's my X variable, it's my Y variable. If your data is formatted into a table, you need to find the hotkey for Autosum. The whole reason you format your data as a table is so you can do the following. Using a PC, you hold Alt and hit equals, and you get an Autosum. A little big sigma down here and a drop down. So I can change this drop down to a number of different calculations, the same calculations that you could do when you do a pivot table. You can calculate an average of X, which is 5.6. You can calculate a count. There are 5 observations. You can calculate a standard deviation, which is 2.7. So if the inputs that we need in order to solve this are the correlation R, X bar, the standard deviation of X, Y bar, and the standard deviation of Y. Those are the 5 inputs that we need. Right now, I have the standard deviation of X, which is 2.7. I copy that in here and paste the values. I'm going to get the average of X, which is 5.6. Paste the values. By the way, paste values on a PC. Sorry, Mac users, on a PC, hit menu and V, and it pastes values. Thank you, PC keyword. Alt down is the way you access the drop-down menu without the touchpad, because touchpads are dumb. I want to calculate the average of those, and the average is 5.8. The average of Y, or Y bar, is 5.8, menu V. Standard deviation of Y is 1.3. Yeah, 1.3. So those are the 5 inputs that I need in order to solve for B and for A. When you do this calculation on the quiz tomorrow and on the exam next week, I'm just copying over the paper. And R equals 0.75. With those 5 pieces of information, there's 3 steps you need to follow in order to do the calculation. Step 1 is solve for B. Step 2 is solve for A. Step 3, input X, solve for Y hat. You're going to be held responsible for the formula for B. What's the formula for B? John?
R times S of Y over S of X.
Right on. 0.75 times the standard deviation of y, which is 1.3. Standard deviation of x is 2.7. I'm going to get something that's about half of 0.75 or somewhere around 0.375. That appears to be my answer. Something that, again, I just did some wavy math there. I don't know if that's a technical term, but that 1.3 over 2.7 is about half, and about just a little less than half. And a little less than half of 0.75 is that value right there, 0.36. But it's also the same value that we found when we mapped that line in Excel. Once we solve for B, step 1, we solve for A, which is actually what we're doing in number 25. What's the formula to solve for A? Gerard?
Y bar minus B X bar.
Spot on. And if we have those three inputs, all I come over here, say y bar is 5.8, B was 0.36, X bar is 5.6. A third of 5.6 is somewhere around 2. That's a little bit more than a third. And that's about 5.7. A third of 5.7 is 1.9. A little bit more than that is 2. 5.8 minus 2 should give you something about 3 and change, a little bit more like that. And hey, true. And now for this last problem, I know that A is 3.77, B is 0.36, and the input for X is 7. That gets me something like 2.1 and 0.42 or 2.52. Okay. Maybe. Add those numbers and you get something around 6.3. When you're given a multiple choice opportunity and you do the math and you don't get a number that's exactly the same as one of these, pick the one that's closest. Or since you have these options and they're so different from one another, 1, 6, 27, you just as well could have looked at the scatter plot and done what we did initially, which was say, if X is 7, my answer is somewhere between 6 and 7, so 6.3 is fine. Now, as we move through these examples, we're going to take less time. I'm not going to shortcut all of them just by looking at the scatter plot, because we could really answer, I think, 8 out of 9 of these questions, probably, maybe all of them. Maybe we'll do the next one and see how fast we can do the next one. But let's go through and make sure we got the answers, starting at 18. 18, independent variable X. 19, dependent variable Y. Nature of the relation, strong and positive. Correlation coefficient, positive 0.75. Coefficient of determination, otherwise known as R squared, 0.57. Out of order G, the value for B, which we saw was around 0.36. The answer for 23 is A. 2F, again out of order. The T test statistic is 1.98. Number 25, the value for A, which is the y-intercept, is around 3.77. And if you input X equals 7, 26A. And that is 26 down. Like a bad crossword puzzle, 75 to go. But hey, that's a quarter of the way through. We've used about 36% of our time. Hi. How we doing? We good? I love the thumbs. I love the feedback. Let me know you're here. We good? I love the thumbs. I love the thumbs. All right, let's keep it moving. Hey, who knew? Part 3, yet another pun. But instead of talking about X's and Y's, I thought I'd be like eggs and Y's, because it's still sort of the same thing. And the mouse is stupid. So if we wanted to do this real quick, one of these is the independent variable, one of them is the dependent variable. Which one is independent, which one's dependent? Independent variable is?
X.
Dependent variable is?
Y.
Y. Right on. First two. What does the nature of that relationship appear to be?
Strong and negative.
I would say strong and negative. I mean, the last one, Alex could barely tell. Well, you could tell. You could totally tell. I know you could tell. We knew it was strong. This one looks stronger. My guess is that R is a little bit bigger than it was before. I say bigger even though it's negative. Let's just go ahead and put the trend line on here and add some characteristics. So I don't know what the correlation is. The correlation would be the square root of 0.79. It could be positive or it could be negative. But based on what we see, it's probably positive or negative. Probably negative. So if you take the square root of 0.79, you get a value that's sort of like, I want to say negative 0.85, 6, 3, I don't know. 8, 9, yep. So if there's a question about what's the correlation, you know it's negative because the line and the relationship is downward slope, it's a negative relationship. The R is going to be either positive or negative square root of R squared. If there's a question that says what's R squared, look at where it says R squared. One of these is A, one of these is B. Which one is A? What's the value for A? Gerard? 19.12. What's the value for B? I want to hear it. Wrong.
Negative.
Oh, you did?
Right. Negative 1.7.
We shouldn't write them with Death Star. It's kind of loud. I don't know. So we started calling something else Death Star, so we can't call this Death Star anymore. It's loud. It's bright. So negative 1.74. If there's a question which is B, B goes with X. Both in the formula for calculating A as well as in this regression. If X is 7, somewhere between 6 and 8, we find 7. The Y value associated with our line there should be something around 6. Is there a Y hat value if X is 7, where Y hat is somewhere around 6? Kelly, what do you see? 6.92. I think that could be the closest one that we have. So if we did this quick, X and Y's, the independent variable is X. Dependent variable is Y. The nature of the relationship is negative and strong, whichever one that is. Weak and strong and negative. Here we go. Value of the correlation coefficient. Well, we could have answered that just by looking at the picture. It's the only one of those which is negative. It's a negative 0.89, and you square it, and that's how you get R squared. 0.79. What's the value of the test statistic? Oh, we didn't do that, but we only have 2 options. You know what? We don't even need to use the formula here. We have 2 options. Negative 4.8 and positive 4.8. Which one is our test statistic, and how do you know other than the answers right under it? Rachel?
The negative A, because it's a negative correlation.
Negative correlation has a negative test statistic. So of the 2 test statistics, negative 4.8 is the only one which makes sense. Which rather than that, because when you have a choice, choose which, not that. Anybody in here actually care about grammar? Yeah? All right.
I like grammar.
We're out there. Don't worry, we're
I'm
out
not good
there.
at stats, but I'm good at grammar.
Let's say you're not good at stats.
I'm not good with numbers.
I'll say you're not good with numbers. This isn't numbers, this is grammar, but actually, all right. 32 down, let's get 33. The value for B can't be positive. B is the slope, and we had a negatively sloping trend line, so it can't be either one of those, and in fact, the value we saw in the trend line was negative 1.74. The value for A, which is the y-intercept, and seriously, if we wanted to look at the picture again for the value of A, rather than this, we could trace this up here, and it would intercept the y-axis somewhere up here, which is probably around 19 or 20. $34, the value for A. Those two would be tricky. The value is 19.1. If we input X, one of those is around what we saw, somewhere around 6 or 7. We just knocked that one out like 5 minutes. That took us 5 minutes. We have 7 to go. Might take us 35 minutes. It'll probably take us a little more because the hypothesis testing might take a little longer. And it's not that we can't just speed through them, because we can, but I want to make sure we're reinforcing the bits that you're going to have to do when you take your quiz and your exam. And then maybe we'll speed things up a little bit as we get closer to our time. I don't know what that means, but I think we just worked. I don't know what that means. The production department of Celltronics International wants to explore the relationship between the number of employees who assemble a subassembly and the number produced. As an experiment, 2 employees were assigned to assemble subassemblies. They produced 15 during a 1-hour period, and so on. Number of assemblers, number of units produced in an hour. Does it appear as though the more people you have working, assemblers, leads to an increase or a decrease in the amount of widgets produced? More people means more or less? More. More people means more stuff. Positive or negative relationship? Positive. Is that clearly positive? Maybe yeah, clearly a positive relationship. That's likely going to be a strong correlation. If we wanted to calculate the correlation using Excel, which we do, we use the correlation function. And the correlation between the number of assemblers and the number of units produced is 0.93. That's a really strong correlation. What you can expect on your quiz and your exam, I give you the correlation. Do not expect to see a scatter plot. I will give you the value of the correlation.
There was a phrase you said to look out for, like, for dependent and independent variables, like,
Mm-hmm.
What was it?
I would say use assemblers to predict production, because you use the independent variable to predict the y. And in this case,
Do you use X to predict Y?
yeah, you always use x to predict y. But in terms of looking at this, if I don't give you a scatter plot where you can easily say, oh, x must be assemblers, y must be production, you can always look at the 2 variables and say one of them makes sense. Use assemblers to predict the number of units, or use the number of units to predict the number of assemblers. The second one doesn't seem to make any sense. You might be able to try to figure out how many people may have been working, but you're more likely, as a manager of Celltronics International, you're more likely to say, if I have 3 people working, how many units can I expect to be predicted? But use X to predict Y. Use the independent to predict the dependent. More questions? All right. Format your stuff to the table, and then change the font because thanks Excel. I mean, no, really, thanks Excel. Alt equals will get you an Autosum, so I can get the X bar and Y bar, the average number of assemblers, the average number of units. I know how I built that chart, and I'm concerned about what I'm about to do. Why do you do this? You don't like me doing that. All right, that's fair. And the standard deviation. So now I have a standard deviation and I have a mean. I have the mean and the standard deviation for the number of assemblers. I have the mean and the standard deviation for the number of units produced. I also have the correlation R, and I can use those things to generate my regression equation. Take some of this stuff to paper. R is 0.93. X bar is, which one's X and which one's Y? Which one's X? Rachel?
The assemblers are X. And the fractions Y.
So the assemblers is X, and the production Y. X bar is 3, Y bar is 24, S sub X is 1.58, and S sub Y is 11.9. Because it's an abbreviation. B equals, what's the formula for B? You're responsible for B. What's the formula for B?
R times S sub Y over S sub X.
Yep. R times S sub Y over S sub X. Remember, it's Y over X. Change Y over change in X. Rise over run. SY over SX. Because some of you are juvenile. I'm juvenile too, that's why I wrote it. 0.93, which is almost 1, basically the ratio of something like this. That should be a little less than, somewhere around 4 or 5. That looks like almost 1, and 12 divided by 1.5 should be 8. No, it's 8. No, 7. I think that value is closer to 7. What's the value for B that you get? 7? Like 7? Yeah, because 1.5 times 4 equals 6, and 6 times 2 equals 12. So there's basically 8 of those in that. So this ratio is 8 over 1. And almost 8 is 7. B equals 7. A equals, you're responsible for the formula for A. What's the formula for A? I think Gerard already gave it to me. Didn't you? Yeah, you did. Anybody else want to give me a formula for A? Help me out. Julie, you got this? Not yet?
Off the top of my head.
Off the top of your head?
Y times BX.
Nope.
Y bar.
Minus
BX bar.
Y bar minus BX bar. Commit that to memory before 10:30 tomorrow morning.
Yeah, I'll do that.
Right on.
In a long bit.
Y bar, the average of Y, 11.9 minus B, which is 7 times x bar, which is 3, basically 12 minus 21 should be something around -9. Is that right? Let's find out. Give me a trend line. Give me some options for that trend line. Oh, wow. It's straight up A equals 3, B equals 7. What did I do wrong here?
It's technically wrong.
Say again?
You round up to this.
I got 21. 12 minus 21. What did I do wrong? We got B right. B goes to X. B is 7. What did I do wrong here? Because 11.9 is just about 12, and 12 minus 21 should be 9. What did I do wrong? Oh, I'm not even looking at it. So I'm looking at. So I'm doing this math in my head, and I see 11.9 minus 7 times 3 is -9. What did I do wrong?
Where'd you get the 3 from?
3 is B. No, 7 is B. X bar is 3. Because up there where it says X bar, it says 3. 7 is B. I got B equals 7. 3 equals X bar. And 11.9.
Well, you're using S sub y, you're using y bar.
That's why you write this stuff out. So you try to avoid those errors. You go too quick. Just make sure these numbers line up to the numbers you got here. That's really about the only error you can make when you're doing this stuff by hand is substituting a number when you should have substituted the other number. B is 3. Sorry, B is 7. B is 7. Y is 3. So if we did 24 minus 21, we would get positive 3. And then if we have 7 assemblers working, we would be extrapolating from our data rather than interpolating in our data. We would probably expect to get something like 50, maybe 52 widgets produced. Or 7 times 7 is 49 plus 3 is 52. In other words, 7 times 7 plus 3 equals 52. Running through. Which one is the independent variable? Rachel, you already gave me this. Which one's the independent variable?
Independent variable is the assemblers.
Assemblers. Dependent variable is production. The nature of the relationship is strong and positive. 38 is D. The correlation coefficient is positive 9.2. The coefficient of determination, and then this thing just goes wonky because thank you printing. And we don't need to see this twice because thank you printing. Or I don't know why that even tells me that the answer is A twice because thank you printing. But we take 0.92 and we square it and we get something that looks like that. So 40 is A. It is also A. I don't know what that's all about. Test statistic. It's got to be one of these. Negative 4.29 or positive 4.29, John?
Positive.
How do you know?
Positive correlation.
Positive correlation gives you a positive test statistic. 41 is positive. B. Value for B we solved for 7. The value for A we solved for is 3. If X equals 7, B equals 52. 44 down, 57 to go, 57, 57, something like that. How we doing? Power on? Keep going?
Yeah.
Keep going. Woo! Woo! Right. City Council of Pine Bluffs. I have no idea where it is. It's probably in either Ohio or Canada. The city of Pine Bluffs is considering increasing the number of police in order to reduce crime. Before making a final decision, the city council asked the chief of police to survey other cities of similar size and shape to determine the relationship between the number of police and the number of crimes reported. Granted, the number of crimes reported is only a proxy for the actual number of crimes because many crimes aren't reported, but when we're talking about gathering information, you have to use the best information that's available. Or, here's a table, let's do math. We want to know whether or not we can predict the number of crimes reported given a certain number of police. So, which one's the independent, which one's the dependent variable? Julia?
Police is independent, crime is independent.
Sounds good to me. Did I add an extra syllable?
What?
I'm blanking on Julia versus Julie. Did I call you Julia?
Yes,
And I'm supposed to call you Julia.
yes.
Okay, sorry. Sometimes it short circuits. I'm staring into a bright light as well. Thank you, Julia. Police is X, independent variable. Number of crimes is Y, dependent variable. If we want to just add some stuff on here, we can add a trend line. And then get the other options that we need. And by the way, if you're working in the trend line, it's the option up there that's got the bars on it. The bars up there is the stuff that gives you what you want down here, which is give me the equation and give me the R squared. And while the R squared cannot give us the R, it can give us the magnitude of R. And if we look at the picture, we should also be able to tell what the direction of the correlation is. So depending on the information that you want, A is about 29, B is about -1, so it appears as though for every police officer we add, we decrease the number of crimes reported by 1. That's what the slope means. By moving X over 1, we move Y down 1. Approximately, it's -0.96, that's almost 1. So add a police officer, 1 fewer crime is reported. I don't think if you have like 31 police officers, or 31 police officers, probably not going to eliminate the number of crimes reported. But at least for the data that we've looked at, we have something that appears to be linear, although I might think that it's slightly shaped. Turn your data into a table. Control T turns your data into a table. And then everything goes away because formatting. But alt equals gets you the Autosum. And by the way, Autosum is great because it doesn't give you just the thing that says sum or average. It gives you the subtotal function. The subtotal function will do average, sum, count, standard deviation. It will do all those things. But how it differs from those functions that just say sum or average, if you hide a row in your table, the calculation will change. If this just said sum, and I said, give me the sum of the sum is 146. If I say I want you to exclude Athens and Cary, it still says 146 because I just used the sum function. On the other hand, if I use the Autosum function, which is subtotal with the argument 109, I can eliminate Athens, and Cary, and it will tally up a new sum only for those visible in the table. Why is it beneficial to format your data as a table? Because doing so allows you to use the subtotal function, and the subtotal function is easily achieved by just holding Alt and hitting equals, and it will subtotal for you. Get used to using subtotals and tables. It makes tabulation and calculation a lot easier. Also note that because the chart is connected to this table, if you, let's say, include or exclude different things, the chart and the equations and the R-squared and all that stuff will change as well. But if we just look at the data that we have, the 7 observations, I think it's 7, 8 cities. Yeah, the 8 cities that we have, this is the stuff that we've generated for those 8 cities. What's the formula for B? Rachel?
It's R times S sub Y over S sub X.
Good. What's the formula for A? Y bar times minus B times X bar. So I think if you're willing to repeat those to me, and it's not the same person every time, we can take the express route to Funtown. I mean, use Excel the way it was designed. That's what I call the express route to Funtown. One of these is the independent variable. We had police on the x-axis, so police is the independent variable. One of those is the dependent variable. Crimes reported is the dependent variable. The nature of the relationship, we said that had a correlation. Oh, we didn't actually calculate the correlation. We only got the R-squared, which was approximately 0.7 something. But we did see our line of best fit was negative. So it's going to be either this one or this one. And it certainly wasn't weak. It's a pretty strong relationship. So I think 47 was strong and negative. The value of the correlation coefficient for a strong and negative relationship must have been negative 0.87. Because looking at that scatter plot, that very good fitting line of best fit gave me something like that. If I take that and I square it, I get, can't be negative, certainly not small, 49 is A. Negative and positive. A negative correlation will have a blank test statistic. Negative test statistic, thank you, Captain. The value for B was that negative slope. The value for A was, one of those two values. Probably that one. When I developed the, yeah, good. 29.38 rounds to 29.4. That could be kind of tricky if we're working on an exam where there's lots of calculators and rounding that I'm not a huge stipulator on. Although the last question on last semester's last exam was, did you follow the rounding instructions for the entire exam? That question may appear on your exam as well. Provided you followed all the rounding instructions and told me yes, or failed to follow the rounding instructions and told me no, there are different ways to get that question right. I'd prefer that you follow the rounding instructions and answer yes, as opposed to choose what you choose and then simply put no. Or A is 29.4. We're definitely more than halfway there at this point. 53, if we had 7 people working, and we said
Basically -1 times 7 plus 29 should get us something approximately 22. That's an awful lot of rounding because on 45i, I put no. That's not I, it's probably, oh. Something like 22. Right on. 53 down, 48 to go. Going strong. We still got 45 minutes to 6:30. Time to talk about mommy car sales. Mommy Ford Mercury Volvo is not where most of my family worked growing up, although most of my mom's brothers and sisters still live in Maumee, Ohio. I did not write these questions, this came from an old textbook I used. My family all worked at the Jeep factory, not the Ford Mercury Volvo dealership. Toledo and Maumee being suburbs of Detroit, Motor City. The owner of Maumee Ford Mercury Volvo wants to study the relationship between the age of a car and its selling price. Listed below is a sample of 12 used cars sold at the dealership last year. I look at that scatter plot, and I know what the independent variable and dependent variable are. What's the independent and dependent variable? Haley, what's the independent variable? Dependent variable? Right on. So age is independent and dependent is selling price. What would you say the nature of the relationship is here? What do you think? Ask anything. Yeah, I mean, maybe, and I absolutely agree with you, because I'm hard pressed to think, you know, there's this guy, so maybe we have something that looks like this, but that's only one of the 12. If we ignore that one, this just looks like garbage. So Excel, do your thing. Give me a trend line if you don't mind. And, ooh, that trend line looks flat. Ooh. Ooh, no, that's no good. That's no good at all. I don't know what I did. Undo. That's why I don't use the mouse. Undo. R squared equals 0.01. The square root of 0.01 is 0.1. Correlation between those two is a positive 0.1. R is 0.1. Non-existent, weak, moderate, strong, or perfect. 0.1, somewhere between weak and non-existent. There's not much of a relationship between how old the car is and how much that car sells for. Even if we exclude, come on Excel, do your magic. I want to exclude, you get me every time. I want to exclude this one car over here that's got an age of 1 year. I just want to see what would happen because I'm curious. And sort of, like there's sort of a negative trend here. R squared is only 0.2 or about 23%. So that would be an R of around negative 0.4, which I suppose might tell us a story. This is the data we're working with, so these are the conclusions that we draw. Age is the independent, selling price is the dependent. Value for B, 0.065, so 0.06. The value for A, 6.4.
Caroline, how do you calculate B?
R times the S sub Y times S.
S of Y divided by S of X. In your brain? All right, make sure it hits the paper. Jill, how do you calculate A?
Y bar minus B times X.
Yep. So if I gave you X bar and Y bar, or rather if I gave you this data, again, not going to give you this data. What I will give you is something like the average of that variable. The average age here is 8 years, and the standard deviation here is 3. So I'll give you an average, an X bar, and an S of X, and you do those calculations. The independent variable, age. Dependent variable, selling price. The nature of this relationship, if R is 0.1, which, by the way, give me the correlation between X and Y. Yeah. You do get a correlation value of 0.1. Correlation is 0.1. That's somewhere between R equals 0, which is non-existent, and R equals 0.25, which is weak. I don't think I could go with weak and positive because it's so small. It's closer to 0 than it is here. Although something like R equals 0.24, I would call weak. 0.1, I would say it's non-existent. Value of the correlation coefficient, 57 is A. Coefficient of determination, R squared, was 0.01, or 1%. 58 is D. Our correlation is positive. Would be C. I can't even circle the right number. Right on. I was joking. 58 is C. I ain't perfect. That's just karma getting me for the multiply and divide that. It's all right. I'm trying to get you ready. Hope you're ready. So the again, we have a positive correlation, so we've got to go with the positive test statistic.
That's what I was gonna say.
I know you were. You want to say it anyway?
You go with the positive test statistic.
Thank you. Sounds better when you say it. Now we got to solve for B, which was a small positive number. It's got to be one of those two. That's too big and that's too big. So that was the number that was put on the regression equation. So that's B. Value for A. Said 6.4 on the screen before. 6.4. And again, we say a car is about 7 years old. That gives me about $7,000 for an expected price, or a predicted price. Predicted. And that number is about $7,000. 6.84 thousands of dollars. $62 down. We've got 40 minutes to go, and it looks like 1, 2, 3 more of these regression problems, and then 2 hypothesis tests for correlations, if I remember correctly. And I remember correctly.
Give me a strategy to efficiently complete these things. I'm easily persuaded at this point. It's the end of the semester, so much so that I wear comfy shoes on the day when I shouldn't. But what do you say? What's a good way to get through these quicker? How do you want to do it? The way we've been? Some other way? Scatter plot? All right. Onward. Bradford Electric Illuminating Company, great job, is studying the relationship between kilowatt hours and the number of rooms in a private single-family residence. A random sample of 10 homes yielded the following. Which one's the independent variable? Number of rooms. Which one's the dependent variable? Kilowatt hours. Kilowatt hours is a metric for electricity usage, just like dollars is a metric for currency. You probably wouldn't want to try to predict the number of rooms in a home just by knowing how much electricity was used, but if you know how many rooms are in a home, you could probably predict the number of kilowatt hours used. Looking at the scatter plot, positive or negative? What's the relationship?
Positive.
Positive. Did you say strong? Why is it a strong relationship?
Well, it looks like it, but also if you like calculate it out using r squared, the correlation is like 0.9.
The correlation is 0.9. So if we do put the trend line on there, which we're going to do in a second, Rachel already did it for us. What's another way? We played guess the correlation. What's another way that we can tell that this correlation is almost around 0.9? What's characteristic of a strong correlation when you look at a scatter plot? What's characteristic of a perfect correlation in a scatter plot?
It's a straight line, so these are all in this direction, straight line, and going up.
Yep. I mean, that's pretty much a straight line. So let's add ourselves a trend line. Let's put some options on there. We're going to get the sunroof and the undercoating. Those are options that you get when you put a scatter plot on there. Definitely not for a car. Hey, we've got A, which is 1.3. We've got B, which apparently is 2/3. We've got R squared, which is 0.82. Square root of which is our positive correlation. It's positive. But again, if I just give you R squared and I don't give you a scatter plot, you cannot calculate R. R could be positive or negative, but you cannot calculate R given R squared. Given R squared and a scatter plot, you could calculate R because the scatter plot would tell you the nature of the relationship. If we had 7 rooms in a home, I would expect something maybe just under 6,000 kilowatt hours, something around 5 and change. So, Kel, what's the formula to calculate B?
R times S sub y divided by x.
Very good. Maybe we want to jump on A real quick.
B times x bar.
What do you do between Y and BX bar? Y bar and BX bar?
Minus.
Yep, gotta make sure it's a minus in there. Cool. So it looks like, thank you, Excel, y hat equals 0.67x plus 1.3, and R is approximately 0.9. R squared is 0.82. And we take 2/3 of 7, we get 14/3 plus 4/3 is 18/3. 18/3, ooh, we should probably get 6, straight up 6,000 kilowatt hours. I believe that. Independent variable was the number of rooms. Dependent variable is the number of kilowatt hours. This is practically perfect, but we're just going with strong. You can't call it perfect, not quite yet. Correlation coefficient is approximately 0.9, 66B.
The value of the coefficient of determination, r squared, is 67, it's 0.82. The t-test is going to be, oh, you've got two of them that are positive here, John. Which one are you going to choose?
I'm going with A. Is that not right?
Well, r is 0.9. Do you think that's a real correlation? Do you think a correlation that is almost perfect? Do you think that is real and true and actually exists?
Yes.
Yes, I do too. If that's the case, we would end up with a large test statistic. A large test statistic means reject the null. Means you reject the notion that rho is 0. You accept the notion that rho is real. All right. I mean, you may be asked sometime in the future how much evidence you would expect to reject the null if you had a large test statistic. If you had a very large test statistic, would you have some evidence, strong evidence, weak evidence, no evidence? A large test statistic. Is a large test statistic evidence to reject the null? Haley, what do you think? It's two answers. Pick one. Pick the first one. Yeah. 5.98 is a large test statistic. It's a real large test statistic because you're always comparing your test statistic to your critical value. Critical values come from the table. So if we go to a table and we look at all of these values, like those values right there are all the values that are greater than 6. Everything else is a critical value for which we would reject the null. In order for us to not reject the null, having a test statistic of 6, which we had in this one, we would have to say we have like 3 observations, maybe 4 observations, or as few as 5 or 6, 7 observations, and looking for a very, very, very small alpha level, a very, very, very small probability of type 1 error. A large test statistic means you reject the null. And 6 is a large test statistic. It would reject the null for all of these nulls. These are the ones bigger than 6. This is big. That means reject the null.
So what, like in terms of evidence, is it strong or weak?
That is very strong evidence to reject the null. This, yeah. That's also in terms of like the standard normal distribution for a t-value. 0 is in the middle. Something like 6 is 6 standard error units away from the mean, which is like 6 standard deviations, like it, but not quite, sort of. That's really, really far away from what we expect. 6 standard error units is like out here, real far away from what we expect. A lot of evidence to reject the null.
Okay.
Value for B, that's my value for B. A value for A, that's my value for A. Don't be confused. The answer to 69, the value for B is A, and the answer to 70, the value for A is B. Don't get confused. That's still A, and that's still B, even though that's A and that's B. I've been doing this a long time. So have you. It's all right to get a little nutty. If x equals 7, A equals 6. We saw that by looking at the scatter plot. Part 8 is the next part, because it says part 8. Part 8 is part 8. Call sales, calls, sales. Call sales, calls, sales. Let's take a look. Part 8. Wow. What's the nature of that relationship? Nature of that relationship, what do you say? What do you think? What's your instinct say? You're smarter than you think. What's your instinct, John?
Well, there's two different sections and they're both kind of look positive.
Yeah. I mean, we have some people who don't have a lot of contacts and some people who have a lot of contacts. The people who don't have a lot of contacts, do they make a lot of sales? If you have a lot of contacts, did you make a lot of sales?
So positive.
Yeah. If you got a lot of contacts, you made a lot of sales. If you don't have a lot of contacts, you don't have a lot of sales. Low on one, low on the other, high on one, high on the other. Call it a positive correlation. Probably pretty strong. Mr. James McQuinney, president of Daniel James Financial Services, believes that there is a relationship between the number of client contacts and the dollar amount of sales. To document this assertion, Mr. McQuinney gathered the following sample information. The X column indicates the number of client contacts last month, and the Y column shows the value of sales in thousands of dollars last month for each client sample. So these are call sales, calls, sales. It's a horrible title. Which one's the independent variable?
Number of contacts.
Number of contacts. Which one is this dependent variable?
Sales.
Sales, contacts, and sales. Appears to be a strong positive relationship between the two. If someone had only 7 contacts, I imagine they would probably only have like no sales. I wonder if it's even going to suggest that we have like negative sales. Gosh, I hope not. But we're going to add a trend line. We're going to make sure that we got our information on here. R squared is 0.95. Do you think Mr. McWhinney is going to be satisfied with his hypothesis? R squared is 0.95. That means 95% of the variation in the number of dollars Daniel James Financial Services makes, 95% of that can simply be explained by the number of contacts. His cousin Daniel Bryant would agree. But here we go. We've got an A value, we've got a B value, we've got an R squared value. We've got just about everything we need to answer 72 and so on. B value is about 2.2. A value is negative 12.2. Julia, how do we calculate B?
It's R times sub Y over S of X.
Good. Catherine, how do we calculate A? Very good. A is Y bar minus B times X bar. B is R S of Y over S of X. A is Y bar minus B times X bar. Because you can tell me that, I can give you what we have here. And again, when it comes time to take this stuff on a quiz or an exam, I will give you the average and the standard deviation for both of these, along with a correlation. Correlation appears to be about 0.98.
How would you describe 0.98? Strong. How strong?
Very
How very?
extremely.
How extremely?
Perfect.
I would borderline perfect. I'm not sure if that's the answer here, but let's see what we have. We are going to use contacts as our x variable to predict sales, which is our y variable. The nature of the relationship is, here we go, almost perfect. 74 is B, almost perfect. The correlation of 0.98 is almost 1. The value of the correlation coefficient, 0.98. Thank you, correlation function. Array for x, array for y. If it, array. Because that's what those things are called. Those collection of numbers in Excel is called an array. Coefficient determination. What's a synonym? What's the more commonly, what's the more common way for us to describe coefficient of determination? What do we actually call it on a day-to-day basis? R squared. R squared is coefficient of determination. It's 1% of your final exam. R squared, you take 0.98 squared, you should get a number probably like 95%. 76 is A. The test statistic.
B.
I'm going with B because it's the positive one and it also says B right there. What is the value for B? The slope of the regression line? B, the slope of the regression line, calculated using that formula, is 2.2. And that number is almost 2.2. 78 is A. The value for A is A. So even though the value for B is A, the value for A is also A. Please don't be confused that A is A and B is also A. Because if x equals 7, and we say y hat equals 2.2 times 7 minus 12.2, we get something like 14.4 minus 12.2, 15, I forgot to carry the 1. 15.4 minus 12.2 gets me something like 3.2, which is nicely available. 80 is B. Part 9, Part 10, and Part 11. Shall we? Part 9. Time to save that money. Which, by the way, I hope, I'm going to San Francisco in June. I hope I get to see Little Dicky because he's supposed to be performing at the festival we're going to. I don't know if that's a character y'all have heard of. That guy.
I saw him in Providence last year.
Is he a good show? Is he worth going to see?
Yeah.
All right. Then we'll make it happen. Hopefully. Fingers crossed. Save that money. Cool. Here we go. Mr. James McWhinney believes there's a relationship between, that's not right. That's not even wrong. That's the same stuff in the other part. So, Lil Dicky thinks having nice assets gets that return. All right, there's our hypothesis. In other words, assets is your independent variable, return is your y variable. And we're trying to look at the scatter plot and determine if there's a relationship between your assets and your return, or as one might say, what you get back. I wonder if there's a relationship between your assets
And all right, sorry. But anyway, there's all this stuff here. We've got the Babson bond L, the Galaxy bond retail, the T. Rowe Price short term. It's beating its 5-year Lipper average on the reg, if you want. Here we go. We got to save that money. What's it look like, the nature of the relationship between our x and our y variable? Does there appear to be a relationship between x and y? No, there does not. So r and r squared are probably close to? Yeah, they're probably both close to 0. If I'm going to calculate b here, who wants to calculate b for me? Who's got that b for me? Cassian? The formula. I can do Excel. The formula?
R times S of Y over S of X.
S sub x, yep. So b equals r times s sub y over s sub x. You got that b for me. Who's got that a for me? Colin? Y bar minus b times x bar. Thank you, sir. Because you have provided me with the secret phrase, the catchphrase, the password, the open sesame. And by the way, I hope at this point, having seen the repetition of generating these things in Excel, that you're able to generate, oh gosh, that's just poor. Look at that, r squared, nothing. Those two very random numbers have better correlation than that. That's just you generally expect somewhere around, it looks like 8 to 10% is what you expect for your return, regardless of how nice your assets are. Or how big your assets are, but. Or how many assets. That's not how many, because it's not a count. It would be how much assets you have. I don't know. Check my grammar on that. But we've got a b value, which is, how would you describe that b value?
0.
Yeah, I would too. Even rounding, that's pretty close to 0. And in fact, because b is 0 and it's flat and horizontal, a, that's probably what y bar is. You calculate a by taking y bar minus b times x bar. B is 0, so 0 times x bar is 0. A equals y bar. So the average of the return rate is probably somewhere around 10%. Table, yes, I've got headers. I know this is my return percent, so all equals, that's the average, is, yeah, 9.8. So 9.9 is A, the average return rate is 9.8. Because their slope is 0, different from no slope is vertical. Because the slope is 0, A and X bar, or sorry, Y bar are just about the same. So the independent variable, we were trying to use our assets to get some return. The nature of the relationship is that it is non-existent. There's no relationship between your assets and your return. The value of the correlation coefficient is either going to be negative 0.05 or 0. It's probably worth calculating. Those two things aren't discernible. Negative 0.05. 84 is A. The coefficient of determination, which is what you get when you take that and square it. Something like one of those two. Was r squared on there? What was the value for r squared?
0.
Is it 0? 0 proper? Yeah, 85 is D. 85 is D, 0 proper. Time to come up with the value for a test statistic here. T equals R times the square root of n minus 2 over
square root of 1 minus r squared. Now granted, we end up with 0 times the square root of, I don't know, something, it's a hamburger, divided by the square root of 1 minus r squared is 0. So basically we get 0 times the square root of, I don't know, chicken fingers. Doesn't matter. Over the square root of 1, which is 1. 0 times something over 1 should get us a test statistic of somewhere around 0.
We don't have to memorize that formula, right?
That formula is given to you. I'm not comfortable with A though. As close as A is, John, B, clutch. Because R, as close as it is to 0, is technically negative. So you're going to have a negative test statistic. 86 is B. B was that value around 0. 87 is A. The value for A was something around 10. Don't be confused. The value for B is A. The value for A is C. 87 is A. 88 is C. 89. If X equals 7, I still expect something around 10% return. It doesn't matter how many $1 million or $100 million of assets I have. I still expect somewhere around 10% return. And now it's time for our wrap up. Let's get at everything we've got, because we've got something like 11 questions to go. 12, actually, 12 questions. It looks like there's 6 apiece because 0 starts or not. Weight and luggage. This is something that's actually a little bit different. So real quick, the 6 questions that we have to ask, or that we answer here is, first of all, what's the value of the test statistic? And then we're going to say the nature of the hypothesis. Is it directional or non-directional? And then we're going to answer, is this a 1 or a 2-tailed test? And then we're going to answer, what's our degrees of freedom? Then we're going to get our critical value. And then we're going to basically accept or reject to decide the nature of the relation. That's all we're doing. A regional commuter airline, oh fun, selected a random sample of 25 flights. Sample size is 25, N is 25. And found that the correlation between the number of passengers and the total weight in pounds of luggage stored is 0.94. R is 0.94. We want to test this hypothesis at the 0.05 significance level with these 6 things. First of all, the value for, what do we use when we're doing a correlation? T or Z? T or Z? What do we do for correlation? T. We use T. R, S, and T hang out together in the alphabet. R we use T, S we use T. T. Now our test statistic T is R times the square root of N minus 2 equals R times the square root of N minus 2 divided by the square root of 1 minus R squared. R times the square root of N minus 2 divided by the square root of 1 minus R squared. That formula will be given to you. If you calculate the test statistic, it's big. 13 is a big test statistic. Remember when we looked at this? 13 is a big test statistic. There are only 6 numbers on our table which are bigger than 13. A test statistic of 13 is 13 standard error units away from the mean, which is 13 standard error units away, really far away. The correlation of 0.94 is almost perfect. With an almost perfect correlation, of course, you're going to have a giant test statistic because it's great evidence that this relationship is real. I'm winded. The value of the test statistic? Something like 13. Is this a directional or non-directional test, and how do you know? Directional or non-directional?
Direction.
How do you know?
Because there's a greater than or less than symbol.
Exactly, because there's a greater than symbol there. So is there a one or a two-tailed test here? One-tailed test, because directional hypotheses have one tail. Right on. How many degrees of freedom? Our sample size is 25. How many degrees of freedom? 23. There are 23 n minus 2 degrees of freedom. N minus 2 degrees of freedom. The critical value we're going to look up in the table in a second. But if your correlation is 0.94, almost perfect, I bet we're going to say we reject the null. Oh, did we say what the alpha level was? I can't remember.
0.05.
Was it 0.05?
Yeah.
Thank you. So 0.05 alpha level with 23 degrees of freedom. I think 1.714 is our critical value, and it's a positive 1.714 because the relationship's in the positive direction. So 90, our test statistic, something like 13.2. This is a directional hypothesis. Rho greater than 0 is the true correlation positive. This is a one-tailed test because directional hypotheses have one tail. Our degrees of freedom is 23. Our critical value was 1.714, wherever that table went. And the nature of the relationship real and it is perfect. Sorry, it's real and it is positive. Last question, part 11, part 11. Finish strong. The Airline Passenger Association studied the relationship between the number of passengers on a flight and the cost of the flight. It seems logical that the more passengers on the flight will result in more weight and more luggage, and will in turn result in higher fuel costs. For a sample of 15 flights, the correlation between the number of passengers and the total fuel cost was 0.667. Test this at the 0.01 significance level. That's our hypothesis. Is that a directional or a non-directional hypothesis? Maybe, Julia, just crush this. Directional or non-directional? Is that one or two tailed? How many degrees of freedom? How many flights? 15 flights. So how many degrees of freedom? 13 degrees of freedom. Critical value, we're going to look up in the table, which is a one-tailed hypothesis. You need three things. Number of tails, one-tailed hypothesis. 2, you need significance level of 0.01. And 3, T or C. T or C, which one is it? T, it is T.
So for ours, it's 23, 25, or 24 for the degrees of freedom. You think that's just 23?
Yeah, that's because I can't do anything right, John. I would pick 23, because that's what the answer B says. Which I meant 13.
So it's A.
Yeah. But check this out. Rather than type in that formula again, I'm just going to come back to the one we already built and said we had 15 flights and the correlation was 0.667. So my test statistic should be something around 3.23. That's why you build the calculator once. That's why I recommend to you, if you have a programmable calculator, that you set yourself up a program where all you have to do is input the sample size and the value of the correlation, and you get an output for your test statistic. Saves you time,
Get you out of here by 6:30 almost. Ooh, maybe actually. Let me slow this bit down. So see if we can get there. The value of the test statistic we just hit at about 3.22. Thanks, Excel. Is this a directional or non-directional hypothesis? I believe this is a directional hypothesis. Is this a one or a two-tailed test? It's a one-tailed test. I'm at 13, so choose A for 99. 100, the critical value, we need to look up. This was a one-tailed hypothesis. Alpha was 0.01, and we had 13 degrees of freedom. Should be something around 2.65. We have an option that says 2.65. I think so. Question 101. The nature of the relationship, it is real and it is positive. Hooray! Hey, you have a quiz tomorrow. You have an exam next week. You have completed your homework. Thank you for all the homework help. This would have been really boring if none of you showed up, because I probably would have done it anyway. But it's much more fun when you are here. Thank you for sticking around. I'll see you all tomorrow morning or tomorrow afternoon. Shoot, I got to pick up the confetti. Well done, y'all. Well done.
I have one question.
What's up?
So if we accept if we reject the null, then it's gonna be real and positive?
Yes.
Okay.
Yes. Because the null says, the null is a statement of equivalence. The null hypothesis says, for our example, this is the correlation, the real correlation is positive. If we reject the null, we conclude the true correlation is positive.
Okay. Real and positive.
Yeah.
And you said you'd like on the quiz, like you'd be like, they think that correlation is positive, right? That helps us determine.
Oh, to the tails and the directionality? Yeah, it will say, test the hypothesis that these are negatively correlated, or test the hypothesis these are positively correlated. That would be directional. Or I would say test the hypothesis that these are correlated.
Okay.
If I just said that these are correlated,
Then it's
HO is equal. HO row equal.
okay. And then not equal is.
Right. I just say, are they correlated? It's not directional. So it's equal to and not equal to.
Okay. And research is always not equal to.
Correct. Either not equal to, less than, or greater than. For non-directional, it's just not equal to.
Okay. Thank you.